In this video, we're going to look at topic 22, example 3. So use a system of inequalities. The problem states that Malia has $500 to purchase water bottles and a pair of socks. For $3, water bottles were $2 for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one item. And we're asked what graph shows the possible numbers of water bottles and pair of socks that Malia should buy. Okay, so let's start by defining some variables. So we're going to say, we're going to use x and y. So let x equal the number of water bottles. All right, we have two items here with water bottles, and then we'll say let y equal the number of socks. Okay, so there's two situations here, or two inequalities we're looking to make here. One is going to deal with the total number of items. So we're looking at least 200 items. And the other is that we have $500 to purchase. Okay, so let's start with the items. Since x is number of water bottles and y is the number of socks, if we add x and y, we need at least 200 items. So we're going to compare that to 200. At least tells me that it can be equal to 200, but it also needs to be greater than that. Okay, anything under 200 is not going to be enough. So we need a minimum of 200 items. And if we were to add the water bottles and socks together, x plus y, again, that's going to have to be greater than or equal to 200. Our second inequality, I'm going to leave some space here just to kind of talk about this problem too. Our second inequality, we're dealing with money this time. So we have $500 to spend. So we can equal that $500. That's fine. We can spend that money. But whatever we total over here can't be greater than that 500. So it's going to have to be less than $500. Right, so that's the max amount of money that Malia has for this fundraiser. So let's figure out what those values are over there. They tell us that the water bottles are 2. So we would do 2 times x to figure out the total money spent on water bottles. And then we could add 3 times y to figure out how much money was spent on socks. So that's our second inequality. And hopefully that's not too bad setting up. These are usually pretty straightforward, usually some kind of combination of items or prices, and you just multiply the prices times the items, and that'll get you a dollar value. I should have added a graph in here. I didn't, so we'll just kind of work with this. Create something like this. We're going up to 500 and 200, so I'm going to go up by, let's just say 40s. So we'll say 40, 80, 120, 60, 200, 240, 280, and so on. All right, so we'll say 40, 80, 120. No, that's not the right number. We said 40s. So we would have 200, 240, and 280. And then we'll do the same thing for the y values. I kind of know how this is going to turn out, so this is why I picked these specific numbers. But if you didn't have these numbers, you'd be able to figure it out at some point. So again, 40, 80, 120, 160. This is just going to be a sketch, so it's probably not going to be terribly accurate, but it should give us a pretty good amount, or a pretty good idea. Okay. The next thing I want to look at, in terms of this problem, there's 2 ways you can find to plot these points. You can put them in y equals mx plus b form and figure out the slope and y-intercept. Or your other option is, because they're in standard form, I can actually use standard form and my x and y-intercepts to plot this. And I'm actually going to do that for this example. So to find the x-intercept, I'm going to set y to be equal to 0. And really, instead of an inequality, I'm going to treat these as an equal sign. So x plus 0 equals 200. That means x just equals 200. So I have an x-intercept of 200 in this case. Not so bad. The y-intercept, I wind up doing the same thing, but make x 0 this time. So 0 plus y equals 200. Let me clean that up. So then y would be equal to 200. So I have an x-intercept and a y-intercept is 200. Now, in terms of shading, I would want to probably put this in y equals mx plus b form, just to make sure I'm doing this correctly. But what I'm going to do is, this is going to be a solid line. I'm just going to connect. That is not what I wanted to do at all. I'm just going to connect these 2 points. Let's see if this works. There we go. And then I am going to then take this, isolate y by subtracting x. So y is greater than or equal to negative x plus 200. And that's greater than, so that's going to tell me to shade, in this case, above. Okay, so let's use our highlighter, and we're going to shade above here. Screen's not cooperating again. So we don't need this to be shaded completely perfect. We just need to get a good idea of which regions we're looking at. So I'm going to look at all this here. Okay, obviously, you would keep shading kind of to the right and above, but I'm just going to limit it to that. All right, so my second inequality, this one might not be as easy to graph, but I'm still going to stick with x and y intercepts. If anything, it just kind of reminds us that we can use this as an option. So my x-intercept, I would do 2x plus 3 times 0 is equal to 500. So 2x is equal to 500. So equal sign, sorry about that. And then x would be equal to 250. So that's going to be somewhere in here. Again, we're not looking for perfection because we're drawing a sketch. And then my y-intercept, I would do 2 times 0 plus 3y is less than or equal to 500, or sorry, equal. So let's make these equal. So 3y would be equal to 500. And if I divide by 3, y is approximately 133. Is that right? No, 166. Sorry. It's approximately 166. So if I was to graph this, my y-intercept is going to be somewhere right here. Okay, remember this is a sketch, so it's not going to be perfect. It's another solid line, so we're just going to draw that. Not having a good day with this. Let's erase that. Let's try that again. Sorry about this. There's something going on my screen. Let's try one more time. There we go. Okay. And then again, I'm going to isolate y so that I know which way to shade. Probably creating more work than I need to here, but that's what happened. So 2x plus 3y less than or equal to 500. I'm going to subtract 2x. 3y is less than or equal to negative 2x plus 500. Divide by 3. I don't really care what the numbers on the side here are, so I'm just going to leave them. I just need to know where the symbol is. It's less than, so I would want to shade below this graph. So I'm going to shade everything down here. So we'll shade that in. And our solution is going to be in this overlapping region. So let's put a little arrow here, and that's where our solutions are. So the solutions are in the overlapping region. So the question was, what graph shows the possible numbers of water bottles and pair of socks that Malia should buy? So we really just needed the graph, so we don't need specific numbers, but any combination in that shared overlapping region would be solutions. So let's say that we just wanted to try it down here to give us an idea of what's going on. They want to know if Malia can buy 75 water bottles. Remember, that was X, and 100 pair of socks. So 75 water bottles and 100 pair of socks would be somewhere in here. which is not in the shared region. So no, she cannot buy that. All right, that fits the criteria for our red inequality in terms of money, but she's not going to have enough items probably for her sale. Okay. So because we did have to do this by hand, again, it gets kind of messy sometimes, but the general idea here is you really want to make sure you know how to create this system of inequalities. And then once you have the system of inequalities, you have some options in terms of graphing. Since the numbers were a little larger, I thought x-intercepts and y-intercepts might be a little bit easier to do by hand, but you do always have the option, which we've done in the previous examples, of using the slope and the y-intercept once you've isolated y. So hopefully it helps. Hopefully all that makes sense, and you kind of work your way through the mess.